So we determined in the last video that Mercury has this density of 5,430 kilograms per cubic meter. So what we do now is do a bit of comparison to see what this number is like, or what's the deal with this number. Well, okay, let's just get going then. So it turns out that the density of just the Earth, if you think of just the crust of the Earth, the part that we live on, has a density of about 2,900 kilograms per cubic meter. Now you got to remember about how the Earth sort of formed here. So if here's the Earth, and let's say that these green dots here are really heavy elements, maybe like iron here. So the green here is sort of like iron. And also mixed into the early Earth would have been some lighter things like that, like these red dots here. Those might have been the silicates, the light things. And again, when it was a molten Earth, what happens is the Earth can differentiate. And I don't mean differentiation from calculus, but what that means basically is that heavy things are going to sink and light things are going to rise. So the Earth then would sort of take a form that looked like this, where those heavy iron things would sink to the core, and the lighter silicates would sort of be up here on the surface where we live. And so this crust here with the lighter silicates alone has a density of 2,900 kilograms per cubic meter. Like if I just scooped out a bunch of stuff right from there, that's the density that I would get. But now, the Earth as a whole, as the whole thing, if you just consider the whole Earth, not just the crust, has a density of about 5,575 kilograms per cubic meter. So suddenly that's sort of a familiar number. So the Mercury has a very similar density then here as like the whole Earth does. Very, very similar number. Okay, so how do you explain that? Well, a bit of a mystery for a while, because remember Mercury is so small. And the equation for the density then that we mentioned a couple times is the mass of the planet divided by its volume. Okay, so it's a small planet, so the volume is going to be small. Remember the 4/3 pi r cubed. This number here, the r, is going to be small because Mercury is kind of a small planet. And also it's a small planet, so that number, the mass, is going to be small. So you have a couple of small numbers here, like this number is small and that number is small, but the ratio of the two, the density of these two small numbers, sort of is equal to that of the whole Earth, which of course is much larger. In fact, Mercury is about 18 times smaller than the Earth in size. So how do you explain that then? How do you explain that it has this incredible density? Well, it turns out then that one of the interesting parts about Mercury, it is absolutely the most iron-rich, iron-rich planet in the solar system. It has the most iron in it. So if you take this item here, like its mass over its volume, this is going to be a small number in the bottom, and this is going to kind of be a large number in the top because there's a lot of mass there. And so a couple of things that you probably remember about fractions here is that this volume over here is the denominator. And so if you have a very small denominator, well, that'll make a fraction large, right? Because when the denominator is small, the fraction is large. But you also have a very large mass. And so the large number on the bottom, the large number on the top, small number on the bottom, large number on the top, makes this fraction here just kind of big. And and very near that of the Earth. And so that's sort of the way the numbers come down. So the question is then, well, how did this happen? How did Mercury get so much iron in it? And well, what Mercury is known as is sort of like an all-core planet. And why do we know it's an all-core planet? Well, you got to remember where iron goes. Let me just scroll up here again. Remember, I discussed this idea of differentiation with you here earlier, that Mercury kind of looked like this too when it was forming. It was molten, and it was made out of a lot of different materials that happened to crash into one another and things. But it differentiated too, so it had its iron sink down to its core, and the lighter things sort of rise up to the surface, just the way the Earth did. So the issue with Mercury then is it probably looked like this at one point, something like this, where of course this reddish stuff here, that's the light stuff, like the silicates. And then of course this green stuff in here, that's heavy like the iron. So that's probably what Mercury looked like at one point, but the density just doesn't match. The density seems to reflect just this part right here. So it's almost like Mercury is this planet that doesn't really have any sort of light silicate crust. And that's why we call it an all-core planet. And so let me just show you then what likely happened to Mercury. So the all-core planet is sort of what Mercury looks like there, and there's the moon right there. We showed you this graphic before. And so this is sort of a comparison here in terms of these cores here. This is what the Earth looks like, and this is what Mercury looks like. So you see they just look way different. Like here is the core of the Earth, but you see the Earth also has the mantle and the crust and all these other layers of it here, but Mercury is just like this huge mutant core right here, just sticking out like that, and a relatively thin sort of crust or outer layers like that. So how could that have happened? Well, there's a couple theories on this, that how Mercury might have gotten this way, and I'll tell you in the next video.